Welcome everyone here in the conference. My name is Andreas Lippold, and I'm leading the 3D PM management team at ESRI. So I'm looking after the 3D capabilities across ArcGIS. Actually, I'm based out of the Berlin area, so working from home and looking after the requirements mainly from the European market to feed them back to Redlands. And as already said, it's great to be here, although I'm not in person there, but I'm calling in from Vilnius, so it's not that far away. And in this session, we would like to look at how ArcGIS technology is becoming a foundation for digital twins and smart cities. So let's get started. I would start off with the question of what is a digital twin, right? What do we mean when we hear the term digital twin or maybe smart cities? What can become a digital twin? Is a digital twin just another aspirational marketing term? I guess nearly everyone here in this room has a slightly different idea of what a digital twin is. So what I recently did is, just type it into Google to get some answers. So when I type in smart cities, IoT, digital twins, what you get is many, city silhouettes with many connections and bubbles. The same as true for IoT and smart cities. They show connectivity, connecting silos, data communication, right? So this is the main aim around digital twins. And when we look at digital twins, what they are virtual representations of the real world, including the physical objects which we see outside, right? The processes and the real-time behavior these physical objects interact with. So digital twins got their start in aeronautical engineering by connecting a digital representation to a physical world. And now they're starting out to branch into different domains like healthcare, manufacturing, and more. And these digital twins were highly useful for engineering systems, just like this jet engine here. But now when we look at the built environment, right, the city-wide scale, it becomes a bit tricky because this is not a purely engineered system. So the concept of the geospatial city-wide digital twin is a relatively new concept, arising from the AEC industry due to the need for high fidelity models of the project site, right, to make sure assets of a building don't collide with each other. And while this is starting to gain maturity for a project site, for a city, this means simulating projects in context. For example, how does an entire project, building project, affect shadow cars, wind patterns, or how new roadways produce noise in the surrounding communities? And I think you can think about many, many more things, right? And they all happen at the same time, maybe in the same context, in the city context. So when we look at a Gartner survey showing, questioning, the people around digital twins, what we hear is that the digital twin market is forecasted to grow to a $48 billion industry just in the next couple of years, which is amazing, right? And everyone is talking about digital twins. And when you ask those people in this survey, if they plan or use digital twins, already 75% of the people mentioned that they plan to use a digital twin, which means really they are actually going to launch some form of digital twin in the next couple of years. And the actual usage of people asked of the digital twin that we asked, or that the Gartner survey asked people is 13%. Only 13% of the people are using digital twins as of today. And the last one is that 1/3 of the people asked that the digital twin serves multiple constituents, which I would have thought is much more, because when we talk about digital twin, usually it implies that the foundational data service would be reused and not be built for just a particular use case or digital twin, right? And this can impact the work of across different use cases and combine the stuff at the end of the day to make an holistic citywide twin. So when we look at the recent technologies which we have been facing and which are driving this whole encounter of digital twins, then we first see the cloud collaboration piece. So we can stream easily, we can share our data, and many of you are familiar with creating 3D models and exporting them, importing them, putting them on a disk, shipping them over to some place, and then people are trying to import them into their systems. Right, and those cloud collaboration is enabling us to bring together those data sets seamlessly by utilizing the ArcGIS system. As new modes of data collection mature, it's actually becoming rarer that projects include only one type of data collection. The second technology, is AI and ML, artificial intelligence and machine learning. So this will revolutionize data management and maintenance. Many of you have already integrated this technology into your own processes to automate the process of change detection. And this map in the middle is from the Halo Trust, a non-profit focused on removal of landmines. And this is their map of damaged structures in Mariupol, Ukraine, to actually localize damages across urban environments using data that trains a machine to figure out what is a damaged structure and what not. And the third technology is the ability to leverage game engines, right, for geospatial applications. So 3D visualization has always been a more valuable tool than 2D, right? Many, many more stakeholders are involved today in the scenario of solving a problem, right? Not only domain experts. So we need a much more mature way of getting towards a state where all of this creates an environment where people understand what they see, and in order to, and bring all this stuff together and using these technologies supports creating these smart digital realities. And this is how we experience the content. Today, it's changing, it's much richer, more immersive, like in this example here in Utrecht. These experiences are based on a common connected data environment where different objectives can be supported across different industries. And GIS really creates the digital twin out of the natural and built environment and uniquely integrates many types of digital models. And when we look at those different models, we can see that on the path to a digital twin, our customers, you are building from existing approaches to how geospatial data is maintained today. Because it's not so much the data itself that is changing, it's how we experience it, maintain it, and work with it. A modern digital twin allows you to abstract and model everything, bringing together many different information models, right? And this is what we have been doing in ArcGIS a long time. Now we elevate it into a 3D system of record. So when we look at, landscape information models, right? Terrain, topographic, and environmental layers, BIM or building information models, highly detailed representations of structures and facilities, information models for managing networks, such as ArcGIS utility network to manage linear assets and connectivity. And then last but not least, the city information model to support urban planning, simulation, and citizen engagement. And this is really exciting and unique to the power of ArcGIS. Location has the capability to interconnect these various detailed models. Here we are looking at a real-time twin of the offshore wind farm Beatrice in northern Scotland. And this is a simple web application to bring together information about the environment together with the building information model, like this one shown here of the wind turbine. Alongside the network information model, showing the relationships between the individual turbines with larger fields, allowing errors to be traced along this relationship. And here you can see that location is the ultimate integrator of this unlinkable data. And ArcGIS itself has the power to interconnect these models and create value by providing a more holistic view, right? Combining 2D information, 3D information, using game engines, all these things that I have explained earlier, right? To come to this view so that everyone sees what they hopefully should see. And the core value of a digital twin is to enable workflows to simulate experiences in the digital world before you move into the physical world. And for us at ESRI, we are looking at a digital twin more from a perspective of a maturity path, right? Of how a living digital twin can be created. So it's all circled around the 3D system of record. And this ties back to the question in the Gartner survey, that many people think it only serves one purpose. No, it does not. Maybe you start off with one purpose, but the system of record is your system of record, which serves the holistic approach by looking at different problems to solve with different tiers of a twin, maybe. And when we talk about the digital twin evolution here, it starts all with data capture, capturing reality, right? Creating depictions of the world. And then the second tier is the ArcGIS system. And the ArcGIS system is actually the geospatial cloud, leveraging configurable components for visualization, analysis, simulation, and more, right? And this is what we refer to as the ArcGIS system. And then we have the benefits of open data and providing access through open APIs. And till then, it's only a representation of what we see outside. Now we can bring in real-time data, right? This is facilitated by IoT sensors and indoor positioning systems, which can be displayed in real time, or at least near real time. And then finally, we have those applications and solutions. And they follow a certain purpose, as I just mentioned, to solve a certain problem. And we are anticipating, or operationalize them as maybe digital twin solutions, all sitting on the same system of record, looking after several twin tiers that tie up into a higher level twin. The approach we propose is to twin the individual subdomains by defining the use cases, workflows, and modeling needs of various professional user groups and the business cases they are trying to solve, right? And once the core data model is deployed, right, the system of record, we can start to represent and visualize these systems together, extending these systems to solve new challenges. So looking on the bottom tier, it's the reality capture tier. It's not only really reality capture in terms of meshes, point clouds and such, it's also like your vector data, your BIM models, everything that is a representation of the outside world, which is your base fundament for a digital twin. And then you can look into certain areas like an environmental twin, a spatial planning twin, a construction design twin, an operation twin, or even whatever comes to our mind. And then starting with this approach to solve a problem and connecting other data sets to different other applications or different other problems you might need to solve. So let's dive into each of those and give more details. The first step is to leverage existing, maybe aerial images and generate foundational content for a digital twin. And one part of it is a photorealistic mesh, right? ArcGIS Reality has just been released, right? So we have ArcGIS Reality as a extension to Pro, as well as we have ArcGIS Reality Studio as its standalone version to produce these amazing meshes, which could be a foundational element of your system of record. So if we go into one of these examples, let me get into here. So this is the city of Almere in the Netherlands. So, and it shows you nicely, you have a digital terrain model, right? And then you have vector data laid on top of it. Now you can also bring in together this data set with LiDAR point clouds. to better analyze different heights and surfaces, right? Easy approach. And then you can also bring in this detailed mesh out of the reality capture tools and combine it with the 2D data in order to analyze and make this mesh kind of a smart thing, right? So you can easily combine this information to create this first depiction of the world with the help of everything you already got. And suddenly it becomes a 3D system just because of the mesh. And in our cloud offerings, you have many, many more tools, like you can measure inside the mesh. You can get the attributes out of the underlying vector data. What else we got? You can also use some kind of weather effects, to make sure, the scenario you want to come across with is relatively real and feels like real. So there's a lot of stuff you already can do to start creating your real world representation. The next one is the environmental hub or twin, which can be essential for a city to provide data of various environmental situations to stakeholders, to citizens. And maybe a good example for this is the city of Zwolle. And we have a tool that is called ArcGIS Hub, and the city of Zwolle has used it to publish their initiatives along with maps and apps, in addition to their open data portal. And ArcGIS Hub is a built-in data search and discovery. This makes it very easy for anyone to find data and maps and apps. And datasets can be opened and queried in both 2D and 3D, and previews can be explored. And these datasets also then can be downloaded or directly integrated into your own web application, for example. So it's another point of engaging with stakeholders and sharing data to build up this twin for certain circumstances. Spatial planning is another construct which is interesting, and we have two tools for this. One is urban. On the one side, it's a fundamental tool for urban planning. We also have City Engine, which is more alongside a city design, right? So you can create procedural elements within a city and build up a city from scratch, or create procedural content which you then can reuse across ArcGIS to build up your digital twin for your city by using this engine to produce 3D content. Also, both have like this workflow of providing an access to game engines, so you can actually produce nice, appealing outputs or compare certain situations. And in this example, it shows the municipality of Karlskrona in Sweden. It shows you that in Urban, for example, which is an online tool, you can create certain scenarios for different planning situations in the context of the 3D city model, right? And changes can be made to underlying policy zones, such as maximum building heights, for example. And you can actually address a couple of things. Users can also create alternatives on the building themselves, looking at changes to land use, numbers of floors or units, and make a building taller or shorter. So it's an easy to use tool to provide a first proposed design of something new. And then you can actually use these tools to compare the existing situation against what you have planned. And this is actually pretty cool, and all on the same single source of truth, which you can use for other applications. And then you can use it for simulating different noise situations or shadow situations based on your design proposal. The next one to think about is the design and construction twin. And GeoBIM, in this case, has become a very important concept and challenge that the ESRI and Autodesk partnered to help solve. And this is interesting because many, maybe you as well, think that connecting BIM and GIS is a good thing. And indeed it is. But still, we are trying to learn from the GIS side what it means to deal with the BIM information. Where is exactly the benefit? On the other side, on the BIM side, they are trying to encounter what is the benefit exactly to bring in GIS data. And this is a good example of our GeoBIM, ArcGIS GeoBIM application that brings in designs, or it creates a live connection between the geospatial model in ArcGIS Cloud and on the other side of the Autodesk Construction Cloud. So here you see, I think this is a bridge model along the Atlantic Road that stretches along the coast of central Norway. So on the left-hand side, you see the ArcGIS online representation. And then once you click on that bridge pillar, you can actually go into and pull this information out of your repository. And then you can do much more like issue tracking. You can also do some, maybe run forward a little bit. You can also then do the flood analysis and see what kind of effect this has on your design. So due to time, let's move forward. Network is another thing, right? Looking at the network, right? Electric, gas, telecom, water, district energy. So this is a huge field where people try to solve some of their needs with the help of the 2D representations as well as 3D representations, building up a digital twin for operation and maintenance. And maybe this little example shows you nicely an example in Dubai, is it running? Where people are trying to connect both 2D information with representations in the 3D world, like with solar panels here. But still, there's a lot of work to do on our end to connect the BIM information with the networks which we already have in our GIS system. But still, this is an important thing to get started and connecting all the bits and pieces. Like here, you receive information from your assets in the field, right? And then getting an understanding of where you are, what's happening, and how it does affect your further network. And at the end of the day, your clients. Operational twin is probably the last one. This is all about operating a facility, a building, a campus, right? Traffic management, facility management, asset management, wayfinding. So products that come to mind is ArcGIS Indoors, for example, or for indoor navigation, right? Also IPS can be a system which can be used for asset tracking. So your many companies or facilities, plants, for example, use it, or ports use it to find assets where they are. How can I move them from A to B so that I can work with them? So interesting aspects that never have been solved before, instead of sending out people and searching for the assets. One nice example I would like to show you today is the CERN facility, which is the world's largest particle physical laboratory and the Large Hadron Collider in Switzerland. And like a small city, CERN uses GIS to manage 18 sites, more than 700 buildings, and over 1,500 scientists and students conducting research in there. And CERN uses GIS to map and manage their complex equipment outdoor, underground, and inside of buildings. And CERN has a standardized indoor GIS data model across the campus, like you see here. And this means administrators can manage security access to certain floors or spaces within. And staff also have the ability to assign office space, book desks and spaces, right, and meeting rooms, all from a single application. And that's pretty powerful, right? And it's all based on your system of record. So even you do the facility management, you can also do a planning scenario or an environmental analysis, right? And this is all stuff that we can do nicely with our ArcGIS environment, and it fuels and it truly becomes a foundation for a digital twin. I didn't touch too much on smart cities, but it always pops up along those lines of a digital twin. Just to maybe put it into perspective, a smart city is a concept. So cities try to be smart, and they can use many, many, many different tools and digital innovations to do so. Like when I go for a new passport, I can use some innovations, right? And then there are other innovations like digital twins, which are also a tool. It's like a hammer, right? You use this tool for a certain problem to solve. And I showed you a couple of examples here, right? And these are the tools that can be used in order to become a smart city. And the underlying foundation is the GIS that creates this digital twin of a social, natural, and built environment, and uniquely integrates and interconnects many types of digital models, as we have done so many years before with our 2D way of looking at it. Now we are connecting it to a 3D world. We are using IoT sensors. We are using smart devices. We are using AI to learn more, to establish processes, to learn more out of the data. And now it's becoming, a digital twin that can help us to solve some of the problems. And it shows to me that I'm over time. So this is my last slide. And I would like to thank you for your participation. And hopefully we can keep discussing on this topic, because it's a very interesting topic. And for me, very, very important is the workflow, not so much the definition of a digital twin. Thank you very much.